All right, here we go. Exploring angle pairs. This is probably my favorite chapter or favorite section in the first chapter. Let's get started. We're going to be looking at shapes like this where there's a ton of different angles, ton of different information, and we're going to be training our eyes to delete information that doesn't need to be in the drawing. So let's get started. A good place to start is our vocabulary. Complementary angles, two angles whose sum is 90 degrees, meaning they add together. Take a look. I got a green or red and blue angle there. 68 plus 22 is 100 or is 90 degrees. Here's the formula. If I told you two angles were complementary, you automatically should write this equation down. The measure of angle A and the measure of angle B is equal to 90. And then what you do is you just put in the information you know and solve for the unknown. Next up are supplementary angles, two angles whose sum is 180 degrees. Quite common for students to get these two mixed up, but you're not gonna, because you're one of my students. I'm going to tell you a brilliant way of remembering this. C and S, complementary starts with C, supplementary starts with S. Those two letters are in the alphabet, in the English alphabet. How about that? And so what I know is C comes before S in the alphabet. Well, guess what? 90 comes before 180 on the number line. So you just keep that in order and you won't have any trouble. Remember, whenever you're told two angles are supplementary, you should think this equation, write it down immediately. All right, next up, adjacent angles. Two angles that have a common endpoint and a common side. That common side is always right here in between them, okay? So AC is the ray that makes them adjacent. Two rooms are adjacent when they share a wall. And so it's just a very common word. This is what I know over in the right in there. It says angle ABC and angle CAD are adjacent. Make sure you get that. All right, I'm going through this like the big boys. So if you need to pause, you go ahead and put it on pause. I'm moving. Vertical angles, two non-adjacent angles formed by two intersecting lines. So you write that and you're like, what? And so this is what I want you to know. Over in the picture, you'll see angle 1 and angle 3. Notice that when I call them vertical angles, most people think it's because they're up and down. That's not what they're about. Okay, so according to the definition, two angles that are non-adjacent, which means they can't share a common wall, and 1 and 3 are the only two angles, or the angle 1, the only angle that's not adjacent to angle 1 is 3. 4 shares a wall with angle 1 right there. 2 shares a wall with angle 1 right there. So those things are blown out of the water. We can't even use those as our vertical angles just by the definition. It says two non-adjacent sides. So 1 and 3 are vertical, and so are 4 and 2. Basically, way I like to look at it is if I'm looking at 1 and I'm trying to find its pair, I look directly across from it. When I extend the lines that make up angle 1, here's the lines for angle 1, or the rays, right here. If I extend them, they go down and form angle 3. All right, so you just need to get that in order. All right, so if angle 1 and angle 3 are a vertical pair, so 2 and 4 are a vertical pair. Go ahead and write the information in over on the right-hand side into your paper, and we're moving on. I just realized I remembered to put something in here for you. Will you do me a favor? Under this area over here, I want you to put a big fat asterisk. Now, I've already written my stuff in here. I'm going to put it on another slide here in a second. I'm going to jump to another slide. I want you to put the information I'm putting on the next slide just in this area for yourself. I want you to put this. Just put a nice little star, right? And just write and what that's saying is this: vertical, and this is angles, are, and then this word congruent. In a minute, at the bottom of the vocabulary after we're done, I'm going to do that symbols into your vocabulary words. But you've heard me use this word congruent. You should have a basic understanding of that. So go ahead and write down all this information under vertical in your vocabularies, and we're moving on. All right, a linear pair. A linear pair is a pair of angles that form a line. So take a look at the picture. 1 and 2 are a linear pair, two adjacent angles whose non-common sides are opposite rays. So hopefully you know what opposite rays are. If you don't, you need to go back and look at your vocabulary words. The really cool thing is that we know is since 1 and 2 go together to form a straight line, then we know that angle, or the measure of angle 1 plus the measure of angle 2 has to equal 180 degrees. So this angle right here, added up, those two added up, have to equal 180 degrees. Moving. All right, take a look at this. Perpendicular lines, old hat stuff. You should know this one. Two lines that intersect to form a right angle. So there you have it. All right, the word congruent. Two objects are congruent if they have the same shape and measure. So here we have some, angles that are congruent. The reason you can tell they're congruent is, first of all, they have the same measure, 40 degrees. Let me put the degree mark in there. Great, fantastic. And those two angles are congruent. They have the same measure, 40 and 40, but also you can tell that they're the congruent because of the marks here. They have identical two strokes for the for the angle marks there, showing that they're congruent. Down here on the segments, we have two segments that are congruent, and they both have the two little dashes of your scratches on it that show that those are congruent to each other. All right, this goes without saying, a segment cannot be congruent to an angle. Why? Because by definition, they're not the same shape. Okay, and so there's the symbol for congruence. You're just going to write that in there. Also, let me just write it in a sentence. So I might write something like this. So I'll use that symbol right there. It says that angle ABC and DEF are congruent. So from that, you should automatically be able to write an equation between the expression for ABC and the expression for DEF and go ahead and solve it like you would in algebra. That's some nice drawing of the arrows and squiggly lines. I know you probably wish that you could be that artistic. All right, so let's start working some equations and applying our vocabulary words and properties to these things. This is like a linear pair kind of problem. So if you see a problem like this is how you're going to handle it. We're told that angle DEC and angle CEF are a linear pair. What is the measure of angle DEC? Those symbols right there are the less than symbols, but my my software package doesn't have an angle symbol. So I have to use the less than sign, so just recognize it that way. Well, since I learned from my vocabulary words that a linear pair are supplementary, or that they add up to be 180, I'm going to write that equation. All right, so far so good. I apologize. I think I just coughed into the microphone when I was waiting. I didn't think I was recording. So here we go, continuing. I like to underline like terms so I can visually see how to put things together. I'm going to start simplifying and using algebra. All right, there you have it. So just so you know, something pretty interesting, this is the #1 wrong answer to this problem. And the reason is because the problem didn't ask me to find what M was equal to. They asked me to find what DEC, the measure of angle DEC. I got to make sure that I answer the question that's asked. Let's plug some stuff in. I'm almost there. There's my answer. I've got the measure of DEC equals 140, but I've got something missing from the circled area there that I will lose some credit on if I don't catch it. So I want you to just pause it for a second, take a look, see what you think I might be missing, and then resume the thing, and you'll see it all of a sudden appear. I forgot my degree mark. Don't forget yours. Don't lose those simple points. All right, so right at the top of your, or right someplace, vertical angles. This is a vertical angles kind of problem. So when you're practicing class, you can quickly find and identify, hey, this is a vertical angles problem. Go find your sample problem so you can see how you did it. Let's set up the equation. JKL right there with the blue arrow. MKL right there with the red arrow. Let's write the equation again. So we know that those two angles are vertical angles. We start to identify that with our visual clues, okay? They're, and you see that they're vertical, they're across the V, if you will. I like to look at it that way. But they're two angles that are not adjacent to each other. They don't share a wall. That's very important. So make sure you have that. So let's, again, I've said this a couple times. Let's write the equation, but let's go ahead and do it now. Since the equations are, since the vertical angles are congruent, we set the expressions equal to each other, and then we just simply solve. And there you have it. Now, let me just point to you that I'm not watching you, so you're going to have to self-identify here. If you're somebody who, once I wrote this equation right here, just paused it and added each step as I did it, to write it in your notes, you did no thinking about this problem. You just simply wrote it down, and it should not at all surprise you if when it comes time to do a problem like this, you have no idea how to do it. This is how you want to take notes. When I set up a problem like this and I write the equation, such as this one, I want you to pause it and then try to solve it on your own. And then play it out and see if I have the same equations. Now, I might choose to subtract my y's first, but maybe you added your 8's first. That's all cool. There's no order like that. But did we end up with the same answer? Continue to practice that way, and you'll become brilliant at this stuff. All right, this problem is for when you're dealing with supplementary angles. Remember, I was telling you back in the vocabulary, as soon as you see that word supplementary, you should write this. That equation. Now, in this particular problem, we're talking angles 1 and 2, but this is just our general form, right? We're just using the letters A and B. It doesn't matter which one's which. We'll just substitute in the pieces and get going. And there you have it. X equals 2. Number one, wrong answer. Why? Because they didn't ask me for what X was equal to. They asked me to find the measure of angle 1 and 2. It's an angle, so I'll put 65 degrees. And there you have it. Two answers. Let's circle. Because I have my work area clearly designated, I know that the answer here is for that one and that one. Otherwise, you're going to have to take and write in, the measure of angle 1 is equal to 65, circle it. The measure of angle 2 is equal to 115, so that I can clearly see it. Now, save on time. Complementary. We just set up another equation for a complementary. There were complementary angles, but instead of the two angles equaling 180, we'd set it to equal 190. I don't need to show you that. I think that's pretty self-explanatory. So when you look at this problem, there's several different vocabulary words that are kind of being played out here. First of all, I can tell by the box right here that these are perpendicular lines. They form a right angle. Also know that the two angles, we'll call it angle 1 and angle 2, are adjacent angles because they share this common wall. Also, I know that angle 1 and 2 are complementary because they add together to give me that 90 degrees that represented by that box. So some really big stuff there. But simply put, what I want you to do is I want you to put me on pause and write an equation to solve for that x. Don't solve for the x. Just write the equation. This as far as we're going to go on this problem. I just want to see if you can write the equation. Solving it at that point is just algebra. So put me on pause. Did you write the right equation? There it is. The two angles have to add up to give me 90 degrees. That's what it means to be complementary. All right, very good. All right, folks, there's your try it problems. Put it on freeze, write those down, put it on a piece of paper so I can find it. I'm getting a lot of sloppy work, believe it or not. And so many of you are losing and not getting 100% because you're making it difficult for me to find your answers and see your work. If you choose to do that, I hope that you choose to change that as quickly as possible. For those people who are writing brilliantly, thank you very much. You make my job very easy, and I love rewarding that. So copy down the problem. Give yourself some time and space to write in stuff that makes sense. Circle your answers, or better yet, put over on the right-hand side an answer column. And if you're not sure what that means, just see me. Fantastic. See you next time.